Hello students, this is day 3 of the chapter Atmospheric Pressure and its Measurement. And today's objective is variation of atmospheric pressure with altitude. And the topics we are going to discuss today are first, variation of atmospheric pressure with altitude, and second, its consequences. First of all, as you already know, what is the meaning of atmospheric pressure? It is the pressure exerted by air on the surface of Earth. And this atmospheric pressure decreases with altitude. Means as we go up on high altitude like on mountains, the atmospheric pressure will decrease. As you can see in this figure, at high altitude the atmospheric pressure is low, whereas on sea level or at low altitude the atmospheric pressure is high. What can be the possible reason for this? Let us understand that. There are two factors due to which the atmospheric pressure decreases with altitude. Number one is decrease in height of air column with altitude, and number two is decrease in density of air with altitude. Open your book on page number 99. Let's read. Variation of atmospheric pressure with altitude. The atmospheric pressure decreases with altitude mainly due to the following two factors. Number one, decrease in height of air column, which causes a linear decrease in atmospheric pressure. Number two, decrease in density of air, which causes a non-linear decrease in the atmospheric pressure. Now, what is the meaning of linear and non-linear decrease? Let's have a look on these graphs. Linear decrease means the decrease which happens at a constant rate, which results in a straight line graph. And the decrease which is not happening at a constant rate, like here in this figure, in this graph, the decrease is first very rapid and then it becomes very slow. Means it is not happening at a constant rate. Such a decrease is called non-linear decrease. Now, why the decrease in density of air causes non-linear decrease in atmospheric pressure? This is because the decrease in density of air with altitude is not linear. It is rapid at low altitude and it becomes slow at high altitude. Now let us understand these two factors in detail. First factor, decrease in height of air column. As you can see in this figure, above the sea level, the height of air column is much more as compared to height of air column on the above the mountains, right? As we know that atmosphere consists of various layers of air which are parallel to each other, and each of these layers exert pressure on the layers which are below them, right? So as is clear from this diagram, from this figure, that above the sea level height of air column is more as compared to that on the mountains or at high altitude. So more the height of air column, more is the weight of air on the surface, right? So more is the pressure exerted by the air. As you know that with height or with altitude, the height of air column decreases, so the atmospheric pressure also decreases with altitude. Clear? Now come to page number 99. Number 1. The atmosphere can be considered to consist of a number of parallel air layers. Each layer experiences a pressure on it due to the thrust or weight of the air column above it. Therefore, as we go up, the height of air column above us decreases, and so thrust exerted by the air column also decreases, which results in the decrease of atmospheric pressure with increase in altitude. Number 2 factor, decrease in density of air with altitude. As is clear from this figure, near the surface of Earth, the molecules of air, these dots represent the molecules of air, right? So near the surface of Earth, you can see that molecules are very close to each other. They are compressed. Now why they are compressed? Because of the weight of these layers of air, right? This layer of air which is near the surface of Earth, it is experiencing weight of these upper layers, these many upper layers, due to which the molecules of this air layer gets compressed and density of air becomes more near the surface of earth. And at this altitude, you can see that molecules are they are not close enough. They are far from each other, right? Now, why they are not close together? Because there is no much pressure of the air layer which are above this layer. So this is the reason the density of air at this altitude is less, because the molecules do not get compressed due to the less weight of upper layers. So there is one more reason, which is the gravity of Earth. Earth's gravity is more near the surface of Earth, and as we go up, the effect of gravity also decreases. Now, due to gravity, the Earth pulls the molecules of air towards it, right? Due to which the molecules of air come closer near the surface of Earth, they get compressed. So density of air near the surface of Earth is more, and due to this reason, if the density of air is more, the weight exerted by air is also more, so atmospheric pressure will be more. And if the density of air is less, weight or pressure exerted by air is also less, so atmospheric pressure is also less. Now let us understand this with the help of this video.
Pressure, also known as the barometric pressure, is the pressure of the atmosphere of the Earth that acts on its surface, also on all of the life forms present on it. This pressure is maximum at the sea level and continues to decrease as we increase our altitude. Why does this happen? Why isn't the atmospheric pressure the same everywhere? Let's find out. The atmospheric pressure that acts on us is due to the weight of the closely packed air molecules, and these molecules are attracted towards the surface of the Earth due to the gravitational force of the planet. We know that the gravitational force of the Earth is maximum at its surface and tends to decrease as we move away from it towards the space. Due to this decrease in the gravitational force, as the altitude increases, the air molecules move far apart. The density of the atmosphere that is comprised of the air molecules decreases. It gets thinner, and the decrease in the density subsequently decreases the atmospheric pressure. The air pressure for this reason is always less on the mountains and the maximum at the sea level. The average atmospheric pressure at the sea level is around 100,000 Pascal, and if we move to an altitude of a passenger plane, the pressure remains to just about 25 to 30,000 Pascal.
Now, can you tell why mountaineers carry oxygen cylinders with them? Reason is this: because air is thinner at high altitude, so amount of oxygen available is also less. So this is why they have to carry oxygen cylinders with them.
This phenomena makes breathing difficult at high altitudes as the air gets thinner and the molecules continue to move far apart. Pressure also.
Okay, now come to page number 99 on your book. Let's read it. Number 2. Since the lower air layers get compressed due to the weight or thrust of the upper layers, therefore the density of air layers is more near the Earth's surface and it decreases as we go higher and higher. The decrease in density with altitude is not linear. It is rapid at low altitude and is slow at higher altitude. Due to decrease in density of air with altitude, the atmospheric pressure also decreases with altitude in a non-linear way. Now let us understand it graphically. In this graph, it is given on your book on page number 100. Along x-axis, they have taken altitude or height above sea level in kilometers, and along y-axis, they have taken atmospheric pressure in centimeters of mercury. As you can see, at 0 kilometer, means at sea level, the atmospheric pressure is 75 centimeters of mercury here. And as we go up at height, let's say at 24 kilometers, the atmospheric pressure, it becomes less even than 15 centimeters of mercury, right? So it is clear from this graph also that atmospheric pressure decreases with altitude. Now let us discuss about various consequences of the decrease of atmospheric pressure with altitude. Number 1 is nose bleeding may occur at high altitude. as most of you may have gone at hill station and you may have observed that nose bleeding occurs there, right? So reason is this, that atmospheric pressure decreases with altitude, but the blood pressure in our body is more and it exceeds the atmospheric pressure outside. So there is tendency that blood vessels may burst and which results in nose bleeding. So we can say at high altitude the atmospheric pressure is less, blood pressure of our body exceeds the atmospheric pressure, blood vessels in nose burst due to high pressure exerted by the blood, hence the nose bleeding occurs. Now come to page number 99 on your book. Consequence number 1, at high altitude, since the atmospheric pressure is less, breathing becomes difficult and nose bleeding may occur due to excess of pressure of blood over the atmospheric pressure, right? Consequence number 2 is a fountain pen leaks at high altitude. Now this is the fountain pen in which a rubber tube is there and ink is filled inside the rubber tube. While filling the ink in fountain pens, somewhat of air is also there in the rubber tube, right? And when such pens are taken at high altitude, the atmospheric pressure at high altitude becomes less, but the pressure of air inside the rubber tube is more, which forces the ink to leak out. So we can say air inside the rubber tube of fountain pen has pressure equal to atmospheric pressure on the surface of earth. At high altitude, the atmospheric pressure decreases, so air inside the rubber tube of pen exceeds atmospheric pressure, which forces the ink to leak out. Come to page number 100 on your book. At high altitude, a fountain pen leaks. The reason is that normally a fountain pen is filled with ink, contains some air also, which is at a pressure equal to the atmospheric pressure on the earth's surface. When the pen is taken at an altitude, the atmospheric pressure at this altitude is low, so the excess pressure due to air inside the rubber tube forces the ink to leak out. Now you must be able to answer all these questions. Open your notebooks and note down these questions, write down their answers and revise them. Number 1, how does atmospheric pressure change with altitude? Draw an approximate graph to show this variation. Number 2, state 2 factors which affect the atmospheric pressure as we go up. Number 3, why does fountain pen leak at high altitude? Number 4, why does nose start bleeding on mountains? That's all. Thank you.